All right, here we go. So let's get through what we need to get through. I promise I won't let it get to 25 minutes. I might talk a little bit more than usual today, but I think you can bear with me. So we got to talk about systems of equations involving parabolas. It's pretty straightforward. It's something you talked about in Algebra 1, but we just have to get parabolas in the mix here. So this will be a little bit of review and maybe a little bit of new stuff. But do you guys remember back from Algebra 1 what solving a systems of equations even means? Like you have two graphs on the same graph. That's okay if you don't remember what it means. Find the point where they intersect. That's what it means. We want to know, where do they cross? That's what we care about. And there were some strategies that you guys used to do this in Algebra 1. Thank you, thank you, thank you. There were some tactics that we used to do this during Algebra 1. We did solving by graphing, and then you did two things called substitution and elimination. Maybe you remember those, maybe you don't. But we're going to talk about how we do all of them. So let's say I have those two graphs. It says solve by graphing. Let's see if this works. I don't know if it's going to show on the screen or not. You guys don't have to do this yet. But when you do this on your own, when you do it on the test, you'll have Desmos out. And basically, guys, if it says to solve by graphing, all you need to do is graph these two things. That's all you got to do. Normally, we would graph them by hand, but we're just going to use Desmos instead. Okay? So I'm going to get out Desmos, and I am going to graph both these things. So I'm going to type them. Y equals x plus 1/2 squared plus 3/4. Okay, so there's one of them. And then I'm going to graph the other one. Y equals negative x plus 4. Okay, and now what are we looking for? We're looking for where they cross. It looks like they cross at 2 points. Desmos will tell us what they are if you just click on them. They cross each other at 1, 3, and negative 3, 7. So those 2 points are the solutions to this system of equations, because that is where these graphs cross each other. Does that make sense? Is this distracting you? You sure? What are you laughing at, Sarai? You got something to say? Yeah. So what were they? 1, 3, and negative 3, 7. So those are the solutions. It's distracting me. Ugh. All right. Jackson Hole. You been to Jackson Hole before? No. What? Well, yeah, if you guys let me do my job. Okay, does solving by graphing make a little bit of sense? All you do is graph them, you find where they cross. That's it. That's literally all it is. Okay? Let's do the next method. It says solve by substitution, and it is definitely not the same system, so ignore that. Not the same system. So I have those things, and I want to solve by substitution. That's when you plug something into something else. Do you guys remember how to do this from Algebra 1? Anybody? Maybe? First one was graphing. Okay. Now we'll do substitution. All I need to do, here's what I need. I need one variable to be isolated. I need one variable to be isolated in my original equations. Do I have a variable that's isolated? No. Yeah, y is isolated in both of them, which is fine. All I need is one. I got two. That's cool. Here's what we're going to do. I'm going to say, hey, y equals that whole thing. And if y equals that whole thing, I could take that whole thing and substitute it in for y in the other equation. Does this ring a bell a little bit? Maybe? So I'm taking this big piece of junk, x squared plus x plus 1, and I'm just substituting it in for y in the other equation. Because that's what y is. Does that make a little bit of sense? All right, so now I have a new thing. X squared plus x plus 1 equals negative x plus 4. And that's my new equation. Now we need to solve that. And now I need to solve that. All right. So guys, I'm going to give you a pro tip. When you're solving these things, what does it kind of look like? It kind of looks like standard form, but more kind of what I'm getting at is that it sort of looks like a quadratic, right? It looks like it's going to be a quadratic equation because you have an x squared. So when you see that it is going to be a quadratic because there's an x squared, you need to get everything on the same side. Get everything on the same side, okay? So there's a couple ways we can do that. It doesn't really matter. I could subtract all this stuff over here, or I could just take this stuff and move it over there. It doesn't really matter. I like to try to avoid negatives as much as possible. So instead of subtracting all this, I'm going to add x, and I'm going to subtract 4. I'm going to take this, I'm going to move it over here. Is that okay? So I'm going to have to add x, I'm going to have to subtract 4. So it's x squared, and then what? 2x and 1 minus 4 is negative 3. And now I have this equation. Well, we got options. It's a quadratic equation. It's in standard form. We have 4 methods that we can use to solve it. What are the methods? All the things we've been practicing. Okay, so we can factor. What else can we do? Square roots. We can complete the square, or we can do quadratic formula. Oh, I hate that sound. So guys, kind of the trick on these problems, once you get to this, it's up to you. You can use any of those methods. You just got to find the one that's probably going to be most expedient. Can you do square roots? You can't do square roots. Why not? There's 2 x's, so square roots are out. We can't do those. You could do any of the, well, we could try to factor it. You might not be able to factor it. I think factoring is the easiest one to try first. If you want to go straight to quad formula, you can, because quad formula always works, right? But I like factoring. I think if factoring works, it's going to be the easiest way. So let's try factoring first. A is 1, so I need 2 numbers that multiply to negative 3 and add to 2. Negative 1 and 3. All right, what's next? What do you mean plug it in? Yep. So since A is 1, I can just do x minus 1x plus 3. Remember, that's a shortcut. If you can't remember that shortcut, you're just going to do the whole process, right? Where you split up the middle number, you do the grouping thing, you do the GCF. You can still do that, and it'll still work. But if you remember that if A is 1, you can take the 2 numbers, and you're good to go. But if you don't remember that, that's okay. Whoa. So I have x minus 1 times x plus 3 equals 0. Well, that's great. I factored it, but how do I solve it? Split them up. Split them up. Set them both equal to 0. And they're pretty easy to solve, so it's x equals 1 and x equals 3.
-3.
Sorry, -3.
Okay, I did a quadratic formula. What's the difference?
Yeah, it should be. If you did quadratic formula, you get the same answer. If you did complete the square, you get the same answer. All right? That should be the case. And we factored. We factored. You could have done quad formula. You could have completed the square. You would have gotten the same thing. All right, but guys, listen to me. Listen to me. Remind me, we're solving this. So what are you looking for? What were we looking for on this one? We're looking for points, right? You need a point, an x and a y. But right now, all I have are x's. So what am I going to do? Slap it in there, huh? Here's what we got to do. I just have x's right now. In order to get the y's, yep, I need to get the y's. So I'm going to plug in the x's.
Yeah, so should we like choose an x and plug it, or do we need to use a specific one for this specific y?
Well, we need to use one at a time. So I'm going to do it with 1. I'm going to do it with -3. I'm plugging it into one of my original equations, and it doesn't matter which one you do. So just pick the one that's easier. So if this was me, which one do you think I'm going to pick? I'm picking this one. Because it's easier. Just pick the one that's easier. So I'm taking y equals -x plus 4. What is going on here? Go away. I have y equals -x plus 4. And I got to do it with both of these. So first, let's do x equals 1. So I'm taking 1. I'm plugging it in here. Yep. So -1 plus 4 is 3. Okay, and then I got to do it with -3. Be careful. It's -x, right? So it's -3. You guys okay? Yeah, we good? I'm not even wearing the pits. I'm not even wearing them anymore.
Oh, it's the same answer from the one.
It is?
Yeah, 1, 3, -3, 7.
Oh. So I get 7, okay? So here's my x's, here's my y's. My solutions are points, right? So I did this x with this y. So one of my solutions is 1, 3. I did this x with this y, right? So the other solution is -3, 7. Does that make a little bit of sense? So guys, real quick, what we did. We had to substitute. We took one thing, plugged it into the other equation. We solved that equation. We had to use one of our methods. You had to choose which one you wanted to do, okay? The only one that didn't work is square roots. You could have done any other one. So we got our two x's. Once you got the two x's, you plugged them both into one of the equations, one at a time. That got you your y's, and we're rocking and rolling. Cool? All right. So we did graphing. That's substitution. I have one more to show you, and it is elimination. Elimination. I don't know why I have a graph on there, but whatever. Elimination. Do you guys remember elimination from Algebra 1? You remember what the gist of it was? Well, yeah, we did it with 3x3 systems, right? It's one where you're stacking the equations and you're adding them or subtracting them. All right, guys, bear with me for just a couple more minutes. I got 10 minutes before I got to shut it down. This is the system I'm trying to use elimination with. So let's just write the top one. 2x squared plus 4x minus y equals -2. This is the one where I stack them and I'm adding or subtracting them to get stuff to go away. But here's the deal. This has x squared x, y. This has x squared y. I'm missing one in this bottom piece, right? What am I missing? I'm missing x. So if I just write it like this, and I go and try to like add some stuff, well, I can't add these, right? That's not going to work. So instead, I need to add in some placeholders. I just need to make sure the like terms are lined up. And if one of them is missing a term, that's okay. I'm just going to give it a 0. Does that make a little bit of sense? So then I have plus y 2. Now everything lines up. X squareds are with x squareds, x's are with x's, y's are with y's, numbers with numbers. Everything's good. But unless we add that placeholder, that's not going to work. Okay? All right, so when we do elimination, guys, you're really, it's a little bit different than when we were doing it with 3x3s. You're not really like zeroing in on one thing and saying, I want to eliminate that thing. You're really trying to eliminate the y's so that you can just deal with x's. So I got negative y, I got y. What do I need to do to eliminate them? Add them. 2x squared plus x squared is 3x squared. 4x plus 0x is 4x. Y, negative y and y, that cancels. -2 and 2 is 0. There it is. Make a little bit of sense? Well, we still want to solve it. This is our new equation, 3x squared plus 4x equals 0. I want to solve it. Again, you can factor, quad formula, complete the square, but we can't do square roots because there's 2 x's. I'll tell you this, factoring is pretty easy on this one. What's the first thing you should always look for when you're factoring? Greatest common factor. Look for a GCF. Is there a GCF? Yeah, you can take an x out. I mean, it's simple, but it works. So factor out an x. Now this is 3x plus 4 equals 0. What can I do with those? Split them up. Zero product property. You got two things multiplied together that equal to 0. Split them up. So, oh my gosh. Why does that keep happening? Thanks for the encouragement. Split them up. I got x equals 0. I got 3x plus 4 equals 0. Well, this one's done. Yeah, no. This one, it's a positive 4, so I got to subtract it. It's 3x equals -4. Then what do? Divide by 3. Yep. Yeah, if you want to use the decimal, you can. It's okay. We okay with that? So far, so good. I need to do one more thing. What do I still need to do? Still need to find y's. How do I do it? Plug in x. So let's do that real quick. I got to plug in the x's. Which equation do you want to plug them into? X squared plus y equals 2. Okay. Well, 0 is going to be pretty easy. That's gone, and y equals 2. Okay, there's that one. Negative 4/3 might be a little bit different. That's okay. So that's, oh my gosh. No, I'm going to show you what it looks like. Negative 4/3 squared plus y. Well, negative 4/3 squared looks like this. Negative 4/3 times negative 4/3. Because you're just multiplying it by itself, right? Remember how to multiply fractions? You just multiply the top and you multiply the bottom. So it's 16/9. Okay. I got to subtract 16/9 now. Kind of annoying. So y equals 2 minus 16/9. You guys remember how to subtract fractions? Maybe. Let's do it over here. You need common denominators, right? So I'll multiply it by 9. Get 18/9 minus 16/9. And what's that? 2/9. Can you reduce that? Nope. So y equals 2/9. All right, so what are my solutions? The green. 0, 2, and negative 4/3, 2/9. Beautiful. Those are the solutions. Ugh.